All right, today we are going to be talking about parent functions, okay? Our goal, learning target for today, is to recognize the basic shape of parent functions and to write a linear equation. Now, parent functions are something that we are going to deal with to manipulate in our next video, so these are very important to this course. All right, parent functions are a set of basic functions used as building blocks for more complicated functions. Parent functions build families of functions. Wow, that's neat. These are the parent functions that we are going to discuss today and that you are going to be responsible to know. All right, we'll talk about the domain and range for each function. Okay, and then additionally, we'll talk about cosine, sine, e to the x, ln of x, and the logistic function. At the end is a brief introduction because those are coming up later in the course. Okay, so our first function that we are going to talk about today is our constant function. Now, a constant function is something you have seen before. Okay, you've seen before in your classes. Our constant function is just that. It's a constant. So our domain, I can input any number for x and get a number for y. Okay, but to deal with the constant function, it's always going to be the same output. My output will always be the same. So my range is c, whatever that constant here is. Okay, so let's say for example that this was at, let's say this is at 3. Okay, this point was 3. So every single point f of my, how would I write this? F of x would equal 3. Okay, so anytime I input an x, my output would always be 3. So in this example, my range would be 3. Okay. Our next function, okay, is our linear function. This is something, oh boy, sorry about that, I had to sneeze. All right, so a linear function is something that you have seen for a long time, all right, ever since you were a freshman, okay, or even in 8th grade, okay. Linear function is increasing at the same rate, all right. It's something that's just x, okay. That's what you're going to notice about all of these. It's f of x equals x. There's no multiplication. There's no altering of any of these. We're going to alter these later on, okay. But for this function here, no matter what I input for x, what my input is, I should always receive an output. So I can input -1 in for x and get a -1 in for y. I can input -4 in for x and I'll spit out -4 as my output for y as well. Okay? Now linear functions are written in a couple different forms. All right? The form that you are most, are used to most likely is y equals mx plus b, slope-intercept form, where our slope is represented by our m, and our intercept, which is our y-intercept, is represented by our b value. Okay, this is the one you're most used to seeing. All right, it's the easiest when graphing because you have your intercept and you have your slope, and you can just go rise over run. Another form that we're going to deal with, and personally my favorite, is point slope form, where it's y minus y1 equals m times x minus x1. Okay? Where our point here is in the form x1, y1, which is here and here. Alright, and our slope, again, our slope here is still our m value. This y and this x will always be y and x. This y1 and x1 will come from that ordered pair, and those are the points that will change, okay, when writing this general form. All right, lastly, well, we've been talking a lot about slope. Well, how do we calculate slope? Slope, remember, is represented by m. Slope is y2, you're changing y. y2 minus y1, you're changing y over your change in x. Now, I want you to think about this for a second, a little sidebar here, okay? I want you to think about, well, how does finding the slope relate to point slope? So pause the video. So we think about it like this, all right? If I were to multiply both sides by x2 minus x1, I would have y2 minus y1, y2 minus y1 equals m times x, okay, come on, bro, 2 minus x1, okay? So really, I mean, this is just very, very similar. Instead of y2 and x2, It's very similar to point slope. All right. Whoops. So that is where point slope really comes from. That's how we derive point slope form, by multiplying both sides by x2 minus x1. Will you ask you to do that? Not necessarily. No. Okay. All right, let's try writing a linear function. You've been practicing this for years. Okay, so my input is -10 and my output is 12. So if I want to write that as an ordered pair, remember that looks like -10, comma 12. Similarly, input is 16, output is -1. Okay, so to write a linear function, first thing I need to do is find my slope. So m equals y2 minus y1, so -1 minus 12 over 16 minus -10. Just change to addition. Now here's the deal. Does it matter which one you call y2 and x2? No, as long as you stay consistent. Don't do one of these. x1, x2, y1, y2. Don't make that mistake, okay? Please don't make that mistake. All right? As long as you stay consistent. So you should get -13 over 26, which is -1/2. All right, now, I'm going to take this -1/2 and pick this first point and plug into my point slope form. Y minus 12 equals -1/2 times x minus -10 or plus 10. Okay, now you can leave it like this. You can leave this as your final answer. All right, point slope form is easier, okay, because it's just that. It's your point. All you need is a point and your slope. Now, if I wanted to simplify it, okay, because this is math class, we love to simplify, I could just distribute my 1/2 and add the 12 to the other side. Now, this form would be easier for graphing, but we will accept this form up here as well. Okay, so I want you to pause your video and then try this one. Go. Hopefully you actually pause the video. You can see that my slope is 1/3 here. Okay, -1 over -3. You could have had any of these three options. Okay, if you chose the first point, it would have looked like this. If you chose your second point, like that. And if you chose to put it into slope-intercept form, which would have been messy, but is a lot easier to graph, you put it like that. Okay. All right, let's move on to our next function here, our quadratic function. Now, you have seen a quadratic before. In fact, in this class, we've talked about quadratics already, solving quadratics for our intercepts, okay, talking about y-intercepts, talking about our vertex, etc. Okay, but this is our parent function of y equals x squared. So, no matter what x value I input into my function of x squared, I should always get an output. I can square a negative number or a positive number. But here's the deal. When I square something, do I ever get back a negative? If I do -2 times -2, well, two negatives make a positive, so y is always going to be, well, let's get a different color on that. Hello. Y is, let's go purple. Y is always going to be greater than or equal to 0 using interval notation from 0 to infinity. Now remember this point right here, okay? That is our vertex. All right, that's our vertex. Again, that's going to be our, in this case, it will be a minimum. All right. Our next function, the cubic function. One of my favorites because there's a nice, funny nickname for it. Okay, which I'll talk about later. So, again, no matter what x value I put in, no matter what my input is, whether it's a positive number or a negative number, I can input it into the cubic. Okay, no matter what. I can cube a negative number and have an output of a negative number. If I do -1 times -1 times -1, that is, my output would be -1. So in this case, our range is all real numbers as well. A funny way to remember this, okay, I call this, or a lot of people call this, the disco man. Okay, you can think of this as a man here. I'm going to draw a little picture for you because I think it's more fun. There's his disco arms. You know, he's doing the disco. You know what I mean? All right. So he's doing the disco. That's our disco man function, which is the cubic. All right. Absolute value is a very important function as well. Okay, we have talked about absolute value in this class already. You've talked about it before. Remember the deal with the absolute value. It's our distance from zero. So I can take the absolute value of a positive or a negative number, any positive or any negative number. But my distance from zero, or any distance, will always be positive. Okay, so I need my y values to be positive. So again, oh, buckets. I'm going to go from including 0 to infinity. Alright. Next parent function we're going to talk about is our reciprocal function. Okay, reciprocal function is a unique function in that, because of these little red dotted lines, which I'll talk about in a minute. If you think about a fraction, okay, within any fraction, there is a number you cannot divide by. Remember, you cannot divide by 0. X cannot equal 0. Well, that will help us with our domain, okay? That can help us with our domain. Our domain is going to be negative infinity to 0, not including 0, and then from 0 back to infinity. Okay? Remember, domain is left to right, and you'll see here. Excuse me. Okay, you'll see here, when I hit this line, this is an asymptote. This is a vertical asymptote here, okay? Our graph will approach this value of x equals 0, but never touch that value, never cross that line. Alright, it'll get there as close and close and close as possible. Okay, similarly, our range is going to be the same thing. Now, why is that? Our range will be the same because of that asymptote there. Right, but why do we have this horizontal asymptote? Remember, we read range from bottom to top. Well, I see this little asymptote here. Again, our graph is going to approach these values but never cross those values. Alright, so if you think about it like this, well, if y is 0, our function is 0, if I were to solve this, multiply both sides by x, this would go away, be 0 equals 1. Does 0 equal 1? No, never. Never, ever, ever. I never say never, but for real, 0 won't equal 1. Okay? Square root function, sometimes called the swimmer's arm. Okay, the swimmer's arm. Swimmer's arm, like he's doing a little freestyle. Alright, freestyle. Not freestyle rap, but just like a freestyle. That, like, whatever it's called, you know, that stroke, that's what I'm looking for. So, in the swimmer's arm, when we're taking a square root, remember, we can't take a square root of negative numbers, so x must be greater than or equal to 0. Okay, we cannot take the square root of a negative, so I'm going to go from 0 to infinity, and I'm going to include 0. Range, likewise, well, not always. The range will be positive. Okay, our range will be positive in our parent function. If I take the square root of 4, I will get positive 2. Okay, so our range will be from 0 to infinity as well. All right, our next function is called the greatest integer function. This has a lot of real-world applications. All right, in this particular function, our domain is all real numbers. Now, I see that there are these open circles here, but then it picks back up at a closed circle. So no matter what I input for x, I can input any number for x. The range is a little more unique in that you'll only receive whole integers out for your range. I'll only receive -2 here. Okay, there's no decimal points. Alright. Alright, these next couple ones, just a brief little introduction of sine and cosine. Alright, sine is called a mountain, okay, because it's like you're climbing up the mountain and going back down. We'll talk about this later in our trig unit. Cosine is called the valley function because I start up here and I dive into a valley like that, okay. This is the exponential function, things growing exponentially. You'll see this. You've definitely heard about an exponential function before in your classes, but we'll deal with this later on. Another function that we'll deal with later is a natural log, which is the inverse. These two are inverses of each other. Our natural log function. Our last function, which is great for like population, is a logistic function. Okay. Again, we're not going to require that you know the domain and range of these functions just yet. Just wanted to give you a brief little intro to them. All right. There you go.